Hello, and welcome to this lesson in quantitative reasoning. Today we're going to talk about, in a second set of videos here, about sets. This time we're going to talk about some applications of sets, in the sense that we're going to talk about subsets, universal sets, empty sets, things like that. And we're going to apply some critical thinking skills to use the terms and vocabulary we apply. So this is the first of a 5-part video series on the set applications. So here are the learning objectives for this 5-part series. I want you to be able to identify a subset, universal sets, an empty set. Know what I mean when I say I'm given this universal set, do this task. We're going to talk about the difference between finite and infinite. Hopefully those are words you have in your math vocabulary. Finite means it has an end. Infinite means it doesn't. In a sense, that's what we're going to talk about there. We're going to identify subsets and proper subsets. There's a slight difference between a subset and a proper subset, and we're going to use the right notation for that. So there's some more symbols and vocabulary to know. And then we're going to determine the number of subsets and proper subsets in a set we're given. How many possible different subsets or proper subsets can you make? So let's get started on the first part of the content. So subsets. Sometimes a set may contain elements that belong to a bigger, more inclusive set. So we talk about, this slide talks about the set of positive even integers less than 10. I want to remind you that even integers end in 0, 2, 4, 6, or 8. Any integer that ends in 0, 2, 4, 6, and 8 is even. Any integer that ends in 1, 3, 5, 7, or 9 is odd. Even integers are divisible by 2 with no remainder. If I take any number that ends in a 4, if I take 5,024 and I say to you, what's the remainder when you divide by 2? You're going to say the remainder is 0 because 2 goes into it an integer amount of times, or you might say an even amount of times, or it is divisible by 2. So if 5,024 is divisible by 2, it means the remainder is 0. If I asked you 5,025, you could tell me the remainder is 1, because when you divide an odd number by 2, you do get a remainder of 1. So you need to know the difference between even numbers and odd numbers. And there's a little review piece here from our last set of lessons. This set A has a cardinal number of 4. 1, 2, 3, 4 elements. You just count the number of elements. So set A is, you were asked about the set of positive even integers less than 10. Be aware of this word less than. It does not include the 10, just like in other math classes. This is only a small part of all positive even numbers. If I wanted all the positive even numbers, you would be writing for a long time. So the way this is, the way this works is I can say that my set A is a subset. The symbol here means is a subset of set E if E were the set of all even numbers. So A is a subset of E. A is everything in A appears in E. So you can say it's a subset. Now this equal sign means A could be the same size as E, and that would still be true. Now A is not the same size as E. A is smaller. When you think sub, you tend to think smaller. But when you use the subset symbol, which is a sideways, a right-pointing U with a line under it, it means A could have all of the same elements as E. The two could be equal. But if you just say A is a subset of E, or mean A is a proper subset of E, if you leave the equal sign out, it means A has the things in A, all are found in set E, but may not be all of set E. So in order to be a subset, in order for A to be a subset of some other set, you need to be able to find 2, 4, 6, and 8 in that other set. So the set that has to contain all of the things you want is on the right, the A is on the left. A lot of times students get hard to A is a subset of E. A could be smaller than E. That one goes on the left. Just like a less than or equal to sign points to the smaller one, A could be smaller than E. But everything that's in A must appear in E. So here's the formal definition written out. A subset of a set E is a set, and a subset of any set is another set that contains only elements from the set, the original set, in this case it's E, but may not contain all of the elements of E. A is a subset. If A is a subset of E, we write this relation as follows. A, and we use this symbol, this is just a new symbol here, is a subset of E. That is how you read that. Now, there are many other, any set can have subsets. All sets do have subsets. I don't want to get into the universal set yet. I want to look at a definition. So, in order to look at a definition, I want to look at an example. In order to look at an example, I'm going to make a different slide here. I'm just going to put a blank slide. So let's do an example. Let me say I have some set U that is 1, 2, 3, 4, 5. Now notice I'm listing this in proper roster form with the curly braces and the commas between the elements. So that's the set U. And I have some other set A that is just got 2 and 4 in it. And you know these are sets because I wrote them with curly braces. Some other set B that has 2 and 7 in it. Now the question is A a subset of U? Now you look at that and the way you tell is, okay, so I want to know, is everything I see in set A found up here? So I look for the 2. Is there a 2 in U? Yes, there is. I look for the 4. Is there a 4 in U? Yes, there is. So the answer is yes, that is a subset. But if I look at my other set, is set B a subset of U? Well, I look at set B, I have to find a 2 in U. I found a 2. I have to find a 7. If I'm asking if B is a subset of 7 of U, it means there's a 2 and a 7. There's no 7. So there's no, because there is no 7 in U. You have to have all, if for A to be a subset, everything that's in A has to show up in U. For B to be a subset, everything you have listed in B needs to also be in the list for U, and it's not. So that would be an example. My handwriting will get better as the semester goes on. So let's take a look at the definition. I kind of just used this. I knew this was coming, so I kind of just used. So think of a universal set. That basically the universal set is the set you're concerned with in the problem. In the example from a couple slides ago, we wanted to know if A was a subset of all the even numbers. All the even numbers was our positive even numbers was our universal set we were comparing to. Universal set is a set you work with in the problem. So if I asked you to list all the odd positive integers, that'll be an infinite list. But if I say your universal set is the integers 1 through 10, including the 1 and the 10, then you're only going to list 1, 3, 5, 7, 9 when I say list all the odd integers that are in U. So the universal set is the set that contains all the things we're interested in talking about. If we were sitting in a classroom together and I said, I want to know, I want the set of all people in the room who are wearing a hat. The universal set would be the people in the room. You wouldn't go looking through the hallways for people wearing hats. It'd just be the people in the room. So the universal set defines how big a set you're working with, what numbers you're interested in looking at, what ideas you're interested in looking at. So the problem will tell you what the universal set is. If you were trying to deliver newspapers on your street, and you wanted to go sell something to people on your street, the universal set would be the houses on your street. The people who bought And then if in the end, if you wanted to list the people who didn't buy something from you, you would only go through and list the people who on your street who didn't buy something from you. You wouldn't list everybody in the world. So the universal set would be the people on your street. So that would be the context there. The empty set is a set that contains no elements. We call it empty, and there's two ways to symbolize it. You can either symbolize it with this symbol here, which is a 0 with a line through it, or with this. But what you cannot do is this. If you write this, the set braces, and then put the symbol in it, this is now not the empty set. This is the set containing the symbol for the empty set. The cardinality of the empty set is 0. The cardinality of what I've just written over here is 1. So you can either write this or write this. I tend to prefer the first way just because it's easier than writing the braces. So the empty set, for this course, you need to remember that the empty set is actually a subset of every set. So it's also called the null or void set. An empty, null, or void, we will mostly use empty, but you may have heard those expressions before. All right, so I'm going to stop right there, and we'll go on to the part 2 video for the next stuff. So these are the ideas. There was nothing really tricky there. The idea of whether one set is a subset of another was the big important idea here. So I will look forward to seeing you in the next video and in class. Thank you.